All right, so our next topic in chapter 7 is 7.4, and it's about arc length. You'll notice in the title here it says arc length and surface area. Surface area was actually a topic that was taken off of the AP test about 5 to 10 years ago. So I am not going to talk anything about surface area since it's not on the test, but I am going to talk about what it means to find the length of an arc. This is a topic that I think is a perfect topic to do while you're at home because it's a relatively simple topic. It is not a topic that is as visually dependent as the topics that we've been doing, where it really helped to kind of have me in front of you and show you some things. It's a little easier to work with. The calculator entry can be a little challenging, so I'm going to show you that. It also is a topic that is only on the BC test. Even though this chapter that we've been working through is actually a Calc 1 chapter that we should have done last year before the closure happened, this particular topic within the chapter is not an AB topic, so it's actually something that is completely reserved for Calc 2. So first, we're going to start with just a few terminology pieces to make sure that when you see a particular term on an AP test, you understand what it's referring to. So the first is something called a rectifiable curve. A rectifiable curve simply means a curve that has a finite length. So it's not a curve that goes on forever. It has a very definitive starting point and has a very definitive ending point, which is what we want to work with when we want to find length, because we want to find the length being an actual number. And then the second piece is something called a smooth curve, a curve that is continuously differentiable. That's a fancy way for saying it's a curve that you can draw where you never pick up your pencil. So there's no holes, there's no asymptotes, and there's also nothing sharp about it. There are no sharp points because a sharp point would lose its differentiability. So anything that just has this nice kind of smooth look to it would be something that is called a smooth curve. And then if it has a definite start and end, it's also called a rectifiable curve. The reason you may see those terms is because those are the only curves that we can actually find a finite length for, or the arc length for. So when we're talking arc length, we have a very definitive formula. For some reason, the symbol for arc length is like the letter S. I'm not really sure why the letter S is used for arc length, but it is. The idea is this formula is going to help you find the length of this arc. Think of it like a piece of string. Let's say you have a piece of string where we're starting at A, we're ending at B. So there's the start, there's the end. And if you put your fingertips on the ends, and if you just pull that string tight and create a segment, what this formula is going to find is how long is it from point A to point B. So that's the best. I know I've said I'm not a great visualizer. That's the best visualization I can give you, is think of it as a piece of string that you're pulling really tight to get that length. So the formula for arc length, the boundaries are A and B, which is simply just where does the length start and where does it end. And then you take the square root of 1 plus the derivative of the function that's being represented squared. The way the kind of the origins of this formula, it actually is a little bit like a distance formula or a Pythagorean formula. No one's ever going to ask you to prove why this formula works, but that's kind of where it comes from. If it's an equation that's written in terms of y's, which is very, very rare. I went through a bunch of old AP tests and I could not find one example that it was in terms of y's, but I'm still going to mention what you do because it's very little difference. The only difference if it's in terms of y's is that you're going to start at your y value, your low y value to your high y value. So we call those the C and D values. And then when you take the derivative, it's already going to be in terms of y. You're just going to derive it in terms of y. You don't have to do any special techniques with that. It's going to be just your basic derivative rules. So I'm going to take you through 3 examples. Biggest thing I want to take you through is your calculator piece. I know that's the most difficult part for me, so I want to show you some tricks and some shortcuts to make sure that you're not having struggles with the calculator. The other nice thing about these questions is often on the AP test, they ask for the setup only. So they will ask, what is the correct integral that represents the length of the curve from point A to point B? And then you don't have to be as reliant on your calculator. So you're going to be given an equation and a set of boundaries. So the directions will say something like, what is the length of the arc over the interval from, in this case for number 1, 1 to 8, or what is the arc length of this function from 1 to 8. The only thing you really have to do by hand is you have to take the derivative of the function, so you can put it into the formula. So power out front, power 1 less gives you x to the negative 1/3 power, which is the same as 1 over x to the 1/3. And then my formula goes integrate from 1 to 8, square root of 1 plus this derivative being squared. So you're going to have to plug that in and square it. And again, that might be all they want you to do on the AP test, is just show the setup. A lot of times these are multiple choice type questions. If you actually have to find the answer, you're going to go to Math 9. Your boundaries are 1 and 8. You're going to take the square root of 1 plus 1 divided by, I'm just going to call it x to the 2/3 because that's what I get when I square out x to the 1/3. Oh, that's not where I want that. X. You're going to notice a couple things when you do use your calculator. The first is sometimes it takes a little while for the answer to pop up, and the reason is you're asking it to integrate a pretty complex function because of that radical. The other thing that you're going to notice is you're going to get a lot of answers that will not turn out to be really nice rational answers. If you try to turn this into a fraction, so if you hit math and then fraction, it won't. And that happens a lot, not always, but you'll have many that do that. And the reason is because you are integrating something that has a radical in it. And so often radicals create decimals. So when that happens, just make sure you go out 3 places. You could say 8.351 or 8.352. Next one is a little more complicated derivative, and the calculator one is tough with this one. So I'm going to show you a trick that I've practiced that has helped me. So power out front, power 1 less. And then this one, you might want to think of it as 1/2 x to the -1 since the x is in the bottom. So power out front, power 1 less. You're going to end up with a derivative of x squared over 2 minus 1 over 2x squared when you clean it up. So my integral is going to go from 1/2 to 2, or you could say 0.5 to 2, of the square root of 1 plus that derivative squared. So I'm just going to write y prime squared. I'm not going to rewrite the whole thing. So here's the calculator trick that I want to show you. When you have to enter in a complicated function that you need squared, instead of entering it all in at once, one thing that makes life a little easier is if you go to y equals and you type in that messy function that you need to square. So my messy function is x squared divided by 2, and then minus 1 divided by, you want this whole thing to be in the denominator. So I'm going to put 2x squared in parentheses. So that is my y prime that I need to square. And I'm going to show you how I'm going to use it in that spot. So I'm going to get out of that and I'm going to go to Math 9 and start my definite integral. So I'm going from 1/2, which is 0.5, to 2. And then it's the square root of 1 plus. So now I want to use that derivative that I typed into y1. So I can actually call that equation back by going to the variables button, the one that says VARS, going to the right where it says y variables and hitting function. And I called it y1. So I'm just going to hit enter. And then I'm going to square it. And the reason that makes your life easier is because when you're trying to put something in that has all sorts of denominators and certain things in parentheses, and then the whole thing has to be squared, the likelihood of you hitting the wrong button or putting parentheses in the wrong spot is so incredibly high. I've made this mistake myself all the time. And there's your answer, 2.062 or 2.063. This one actually will go to a fraction. If you wanted to write a fraction, you could. It's, what is it? 33/16. So either answer would be fine. As far as units, when you get to the end, and if you're wondering what should I put for units, this is just representing a length. So it is just units, nothing squared, nothing cubed. All right, let me do one more with you. I want to show you a trig one, just because sometimes that's what they'll do with this, is just make the derivative a little messier to test kind of another skill as you do this. So the derivative of a natural log is going to be the derivative of this over this. So the derivative of cosine is negative sine over cosine. So you end up with a derivative that is negative tangent. So your integral is going to go from 0 to pi over 4 of the square root of 1 plus this derivative. When I square it, is going to end up being positive. The negative will cancel. So it's 1 plus tangent squared. This one actually gets really simple. I saw this show up on an AP test once, and at first I thought, like, what are they doing here? How are they going through this? But with some basic identities, it cleans up really nicely. 1 plus tangent squared is an identity that you should know. It's a Pythagorean identity, and it equals secant squared. So I can actually replace everything under the radical with secant squared. And then the next thing you should notice is a square root and a square cancel. So you are just integrating from 0 to pi over 4 of secant. The one that I saw in the AP test like this, it didn't actually want a final answer. It wanted to know which of the following represents the length of the arc. And then it was interesting because the problem started out with natural logs and cosines, and the right answer ended up as an integral of secant. And you might wonder how it got from point A to point B. If you have to do it on your calculator and actually get an answer, make sure you're in radian mode. You're going to go to Math 9. My boundaries are 0 and pi over 4. When you're integrating secant, since there's not a secant button on your calculator, you're going to type in as 1 divided by cosine because they are reciprocals. And then let the calculator do its work. Again, you get a decimal. It's not going to go to a fraction. You're putting pi in, you have trig in. It's kind of a mess. So we're just going to type in 0.881. So that is your lesson on arc length. It is nice that you don't have to worry about drawing pictures with this lesson. Your homework assignment is to go into AP Classroom and complete the, I think it's 8 multiple choice questions all about arc length.